Okay, so this is 11.6, example 5. And I think this one's going to be kind of fun, interesting. And let's get to it. So you're probably freaking out by looking at this big thing. You're like, oh my gosh, this looks different than all the other ones. And it's like, oh, what is composite solid? What is that? Basically, you got a solid here and a solid there, and you're going to find the volumes of both of them and put them together. Okay, composite them. And that's what we're going to do. So the volume of a pyramid from the latest core concept that you wrote in your notes equals 1/3 times the area of the base times the height. Okay, that's for a pyramid. And then we have the area of this cube, or the volume of the cube, which equals length times width times the height. Okay, so the length times the width times the height. And this is easy to find for a cube. So let's go ahead and find the volume for the cube. Then we'll find the volume for the pyramid, and then we're just going to add them together. The volume of the cube is going to equal to 12 meters times 12 meters times 9 meters. And 12 times 12 is 144 times 9 is 1,296 cubic meters. Okay, now let's find the volume of the pyramid. What we notice is, let me change this color actually. We can see that this 10 right here is not the height. Don't be fooled by it. You see how it's slanted? It's along the face of this triangle. The height comes straight down to the center of the cube, making a right angle, okay? And so I could continue this three-dimensional triangle coming straight down from the tip of the triangle going down the center of the pyramid to the very center of the base of the pyramid. And this line here is halfway across. So this will be 6 meters. How do I know that? Well, all the way across is 12 meters. Halfway is 6 meters. All right. And we have this side, which is 10 meters. So in order to find the actual height, the height that we need, we're going to use Pythagorean theorem because this is a right triangle. Okay, the unknown height, we have 6 because it's halfway across this square, and when they gave us this line here, which is 10. So the Pythagorean theorem is c squared equals a squared plus b squared. Now, c squared, c is always going to be the hypotenuse, which is the longer side. So this is c, which is 10. 10 squared equals a squared, 6 squared, plus our unknown. All right. And so we're going to have 10 squared minus 6 squared plus or equals b squared, square root, and it gives you b. Okay. Because we're taking the, well, b squared, we're going to take the square root of both sides. Okay. And so if I do 10 times 10 squared is 100, 6 squared is 36. We have 136. What's the square root of 136? Wait, 100. I'm sorry, we're not adding them together. We're subtracting them. My bad. Subtraction. 100 minus 36 is 64. Aha! And the square root of 64 equals 8. Okay, so that is going to be our height right here, okay? So this is going to be 8 meters. Now we can plug this in to our volume formula to find the pyramid. So the volume of the pyramid is going to equal 1/3 times the area of the base, which is the area of this square So the area of a square is width times length, 12 times 12, 144, times the height, which is 8. That just matched up perfectly. Okay. 8 times 144 divided by 3 is 384 cubic meters. We are not done though. We have to take this and add them together. And then that will be your final answer, okay? So I'm just gonna take that plus 1,296. I get 1680, and that is my answer, 1680, and it is correct. That's the correct answer, okay? Because I just added these together. That's how you do it, guys. That's not very difficult, okay? Just stick to the mathematical concepts that we've learned, and use your notes. If you've forgotten, go back and check your notes. You'll do great. I have faith in you.